Okay, so I'm going to go over the Unit 3 review Part 1 questions. So question number 1, the table represents some points on the graph of a linear function. Which function represents the same relationship? So we have our table of values here. We have x and y. So the top row is x, the bottom row is y because our table is horizontal. And then if you notice here, we have our answer choices. So I can check a table of values or an ordered pair or a set of ordered pairs in my calculator if my equation, my linear equation, is in y equals, because I can go to the y equals screen and then go to the graph. So I'm going to go to my answer choices and see if I need to rearrange them first. And I notice that they are in y equals mx plus b format. And some of you may be looking at this going, well, I don't recognize that. When we talked about function notation in Unit 1, I said if you have a variable and then x is inside the parentheses, that is another name for y. Because remember, we're going to get to where we're working with more than one linear equation. And we've got to be able to differentiate and tell the two apart, so we can't just keep saying y equals. We've got to come up with another name for our function. So this really is just y, since we're working with one single equation. So I can think about it as y equals 1/5 times the value of x minus 12.5. Y equals -5 times the value of x plus 2.5. And so on and so forth. So I don't have any rearranging. Now it becomes a check it in my calculator. So I'm going to clear my memory. I'm going to go to y equals, and I'm going to type in answer choice A, exactly like it's written on my paper. So I'm going to go 1/5 x minus 12.5. Now, if you want to check a set of ordered pairs from this screen, you have two choices. You are either going to graph it and see the picture, or you're going to go to the table which lists all of the ordered pairs, but remember, only the whole number x values will be shown. Well, if I'm checking pairs, ordered pairs, I want to go to the table. I don't want to go to the graph. I can't read the exact ordered pairs as well. So, okay, -3.5. Remember, we're not going to see -3.5 because it is not in the x column. I'm only seeing the whole number x value. So I'm going to go to the ones I can check. I can check -1. And it should say for y, -12.7. Well, look at the y value, -17.5. That's not even close. So A can't be our answer. So I'm going to go back to y equals. I'm going to clear it out. I'm going to put -5x plus 2.5. And then I'm going to go back to my table, second graph. I can't check -3.5 because, again, it's only showing whole number x value. So we'll deal with that in a second. Now I'm going to check x is -1. It should say -17.5 in my calculator, and it says +7.5. That can't be my answer because it has to match in both tables. So now I'm going to go back to y equals, and I'm going to type in -1/5 x plus 2.5. And again, I'm going back to my table to check my ordered pairs. So we already said we can't check the first point. I'm going to go to -1. And in my calculator, it says 2.7, but on my paper, it says -17.5. It can't be that equation. So now I'm going to go back to y equals. I'm going to type in 5x minus 12.5. I'm going to go to my table. -1, -17.5. Check, it has it. Now I'm going to check 0. It should say -12.5. It has it. Now, 2.5, I can't check. I can check 4, though, and 4 has 7.5 for its y value. So if you want to check x values that are not, here's how you do it. You go second table, and you go down to ask for independent, because remember, Dixie-Royd independent is another name for your x values. Set it to ask. Now the calculator is going to ask you for your x values. I'm going to go back to the table, and you notice it's all empty because the calculator is asking me for an x value. What's the x value I want to check? -3.5. And it says -30. The next x value I want to check is 2.5 because it's not a whole number. And I got 0, which is exactly what the table on the paper said. Now I'm going to check 6.5. And again, my calculator is asking me for an x value, 20. So D does work. And I'm going to put on here y equals. And then we're going to say second graph. I'm going to use my purple instead of my blue pen. But remember, second's the blue button. And that is how you check for an ordered pair. 1, 5, a whole table full of ordered pairs, but your equation has to be y equals. So that's why we've been practicing solving for y. All right, look at number 2. An organization has a monthly budget of X dollars. Every month, $2,070 is spent on salaries. 1/4 of the remaining budget is spent on monthly activities. Which function can be used to find the amount of dollars spent on monthly activities? Okay, so we want to find our budget is X dollars. So we're starting with X. X is our budget. Okay, so that's how much we have every month to spend. Okay, that's our total. So when you're given a budget, that's like your total amount. Okay, so we want to spend monthly activities. Well, is salaries monthly activities? No, because it would say 2,070 is spent on monthly activities. So I don't want to worry about that. I want to get rid of it, take it away. I'm going to actually put over here, not activities. Okay, so if it's not an activity, we're not going to be spending it on that. So again, we want to get rid of it. We want to take it out of our budget. So mathematically, what would we need to do to take away what is spent on the salaries? Will we add it, subtract it, multiply it, or divide it? We got to think mathematically now. And hopefully you said that you would be subtracting, getting rid of, taking away. Okay, so let's pretend we have this pile of money here representing our budget. We take out what is spent on salaries, and what we have left is the remaining budget. And it says that 1/4 of the remaining budget is spent on monthly activities. So I have to take whatever's left and divide it into 4 piles. And only one of those 4 piles gets to be spent on monthly activities. Well, how can I show that I'm splitting the remaining budget, what's left after we take out the salaries, into 4 so that one of those gets the monthly activities? Isn't that the same as dividing by 4? So which one shows that we are taking out our salaries and then dividing what's left by 4 into 4 groups so 1/4 can be the budget? Well, let's see. Here we're not adding the salaries to the budget. That salary has to come out of the budget, so A can't be it. Okay, here we're subtracting, but are we taking the budget away from the salaries? No, because it says the budget is our total, so we should be taking the 2,070 away from the budget. So this has it backwards. Again, we're not adding because our salaries comes from our total, so we wouldn't be adding them together. So that only leaves D, which shows us that we have to take out our salaries, and then what is remaining, what is left, is going to get split equally into 4 categories. One of those categories is our monthly activities.